So I'd like to explain what I've been up to these days, and before that, I'd like to appreciate all the people who subscribe to my channel and people who have commented and gave likes. It really motivates me. So I've been working on LeNet 5, which looks like this. You've got 2 convolutions and 2 poolings, and after that you've got feed-forward neural networks, and the size of image is typically 28 by 28, but normally you'd pad those images so that the size would become 32 by 32. Anyways, so I've been working on calculating gradients. So these are all the codes for that. And also I made some fix to convolution and this convolution function, where so there are 2 cases in this function. When the size of input is 3 or 4, which looks like this. Technically, when it's 3, it would looks like this, but people normally, like in machine learning libraries, it would look like this anyway. So I made a fix when the inputs looks like this, when the number of channel is more than 1. So I was computing convolution in a wrong way before. So when the number of channel is more than 1, you'd have to take dot products between the kernel and all the channels. So let's change the number of channels to 3. And this is the kernel. What you have to do is you take dot products between this kernel and this channel, and after that you compute dot products between this, and so on, and you sum the results. That's what you have to do. When the number channel is 1, like in this case, you just take dot products between kernel and image. It's pretty simple, but when the number of channel is more than 1, you have to do more dot products. So I didn't know that, so I fixed it so that it would compute like that. It was hard to implement, but also hard to understand in the first place. I mean, in the beginning, yeah, and also I could do those are all the to-dos for the optimization, but I haven't done it. But those are the things I could do it later. And also I realized that those two functions, convolution and max pool, I think I could move these functions into layers file, because those functions could be used for all the data sets. Not only, by the way, for this project I'm using MNIST dataset, but you know, those functions could be used for other data sets if it's in 2D, so I could just put it in this file. Unlike all these sequential models like GRU, LSTM, LRNN, I just can't put it in layers because they all have different algorithms for the forward function. As you can see, those are all different. So, and I mean, and also I realized that those sequential functions, sequential models aren't like modern way to deal with sequential data set, like when you're doing NLP. I guess those are replaced by transformers. So, you know, even though I implemented from scratch, I'm not really these days I'm not really interested in those. Yeah. And it's pretty trivial, but I used to declare those parameters, epochs and batch size and layer learning rate up on top of the file, like here, but I just moved them inside the train function because they are only used in this function. So, and also I like to explain how you would compute gradients for C3, which is this. And also before that I like to explain. So these are for the function, essentially this one. You compute C1 all the way to Y, and you'd have to reshape S4, which is this one, before reshaping it. The shape looks like this, but after you reshaped it, the shape would look like this. And the reason I have to do this is you'd have to flatten the result, which is this S4, before you pass them into feed forward function, which is F5, F6, Y. All these feed forward functions, I think they only accept 2D shaped data sets. Like you can't pass like shape, you just can't pass data sets that has shape like this. So how do you compute gradients for C3? So you know max pooling, right? And you just have to choose maximum values from each regions. So in this red region, it would be 20, 30, 120, and so on. So that's so this is 16. So most biggest number in this region is 16. So it would go here. In this region, it would be 31. So it goes here. I guess you get the point. So this is from C3 to S4. But when you compute DLDC3 first, you have to compute DLDS4. Let's say it would look like this. What you have to do is that you move this 40 into index of maximum value, then you take max pool in C3. So in this region, the maximum value was here, right? So you put 40 in here. In this region, maximum value was here, 12. So you put 11 onto that location. I think you get the point. So the final result looked like this. Anyway, so that's what I've been up to these days, and I think the gradients are almost done. And when the gradients and when I'm done with computing gradients, I'm done with this model. So yeah, I think this is it for today's video. Thank you.